All right, in this video, I wanted to focus on intervals and ranges. When we're looking at a quadratic function, so a quadratic function, this one will look something like that. The intervals that we want to know about, like for this graph, the graph is coming down, 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 and then right here it switches. So we sort of want to know where that switch is. And that point, as we know, is it's called the vertex. So at that point, we want to know things about x and we want to know things about y. So the x things that we want to know are, here's x is left, right, right? So when x is going up to that point, what's happening with the graph? So if you look at the graph is coming down. So there'll be an interval from way over here somewhere, negative infinity, all the way up to this point right there. And what's happening during that interval is that the graph is coming down. Then, from that point where it flips, then the interval, if I go from there and I keep going right, what's happening to the graph? Well, the graph is going up. Okay, so I want to be able to describe those intervals, and the whole key to it is finding that vertex. So here's a problem, and let's just check your vertex. So to get the x-coordinate, it's minus b over 2a. So minus something over 2 times something. B is a 6, and a is a 3. So negative 6 divided by 6 is negative 1. That's what you have. And then you have to plug that in. So to get the y value, figure out what the value of the function is when you plug in a negative 1. So it'll be 3 times negative 1 squared plus 6 times negative 1 minus 72. So this would be 3 minus 6 minus 72 minus 75. Perfect. Okay, so let's graph this thing again. So I've got negative 1 and negative 75. Let's put that right about there. So 25, negative 50, negative 75, about there. And that's negative 1. So that's my point, and that's my vertex. Because A is positive, that means the graph goes up. So it'll be going up like that and like this. If we wanted to try and factor, we could figure out the x-intercepts. I could figure out the y-intercept right now. It's just that last number, right? Negative 72. So 0, negative 72 would be the y-intercept. But the information I'm wanting to know is I have this vertex, so it's a negative 1 and negative 75. So how does that relate to my intervals? Okay, so my x's, here I am, x is on the left, right, right? So I'm coming this way, and then right there something happens with the graph. So I need to describe that interval. So all the way to the left, so it'd be negative infinity, all the way up to negative 1. What's happening to that graph is that the graph is going down. Okay, so the graph is going down in that interval. So where's that saying that? Oh, the function is increasing on, and they want to know where it is. So it's increasing from, oh, that looks right, because from here, this way, the graph, so from negative 1 all the way to positive infinity, the graph is going up. So this should be correct. So that'll be correct that, I wonder if the bracket is correct. Would it be increasing at 1? It would be flat. I think that this way of writing it is correct. Okay, so the graph is coming down from negative infinity to negative 1, and the graph is going up from negative 1 to negative 75. So graph coming down, and this graph, it keeps going this way, right? So it would keep going on forever to the left, and it would keep on going up forever to the right as well. But it would, as you go, the further you go right, the higher it gets. But it's always going to be increasing in this interval. So if I go from my x from -1 and I keep going on to infinity, this graph is still going to be going up. Okay, so that's the interval. And then they talk about the range. So they want to know what the range of the graph is. And what the ranges are the y values. So what are the possible y's? And similar to the intervals, you say what the lowest number is and then what the highest number is. So for this interval, the lowest number would be negative infinity all the way up until you get to -1. That's my interval. So with the range, we can do the same thing. So the range would be, it looks like I can go as, let me use a different color. I can go, let's use a nice magenta. I can go up and I can keep going up forever. Like those graphs will keep going up forever. So the highest number has to be infinity, like that. Okay, the lowest number, the smallest it can get down to is -75. And this time it can include -75. So -75 is the lowest that it can go, but it can't include that number. So I put a square bracket there. With these ones here, I put curlies because it can't include -1. Because at -1, at that point right there, it's not going up nor coming down. It's sort of, I guess you can think of it as being flat. But it's a point where it's not going up or down. It's flipping or changing at that point. And that's why they use the curly brackets there. But in this one, -75 is the lowest number it can go. And so we include that with a square bracket. Let me show you just one other one. Okay, I'll make up my own. Let's try this. Y equals -2x squared minus 4x plus 7. That looks like a good one. Okay, let's find the vertex. To do the x value, it'll be a minus b over 2a. So it's minus b over 2 times a. So b is a -4 and a is a -2. So it's this would be +4 over -4. It'd be a -1. And then the y coordinate, figure out f of -1. So -2 times -1 squared minus 4 times -1 plus 7. So -1 squared is 1 times -2 would be a -2. -4 times -1 would be a +4 plus 7. So -2 plus 4 is 2. 2 plus 7 is 9. So my vertex will be -1 and 9. Okay, that'll be perfect. So let's do this on decimals. Here we go. And I'll just try it, plugging it in there. So -2x squared, go over, -4x plus 7. There we go. Okay, let me move that right about there. Okay, so I see the point right there is -1 and 9, just like I figured it. So if I'm looking at intervals, again, I'm thinking x values. So from way over here all the way up to that point right there, so this line right there, well, I guess I could be doing it up here, to that point right there, the graph is increasing. Okay, and again, this goes on forever. So the graph is increasing. So I can say my interval is from -infinity all the way up to -1. The graph is increasing. And then it's decreasing at that point right there. So decreasing from -1 to +infinity. Again, so I'm going from here all the way that way. So I can plug in any x value I want, and it's just going to get smaller and smaller and smaller and smaller. Okay, bracket. So during that interval, the graph is decreasing. Now, if I wanted to look at what my range is, so my range, again, I'm going to put brackets. Maybe I need a square bracket. Oh, do I need a square bracket on these ones? No, I don't, because it can't include -1, because -1 is the flipping point, so I can't include that. So that's why I just have the curly ones there and there. But my range, it looks like I can go down as far as I want, but I can only get up to a certain amount, and that'll be my +9 value. So my lowest value, it goes on forever, so my lowest value would be -infinity. And then my highest value would be a +9. And I can include a +9 because it can reach, the y value is 9 at that point, so it can include the 9. So that would be my range. All right, hopefully those two videos sort of help clarify that idea of intervals are left-right things and range up and down.